Welcome to the Explainer. Today, we're going to unravel a literal mathematical superpower hidden inside an old, seemingly simple fairy tale puzzle. You know, we hear the term exponential growth thrown around all the time in the news or in science, but what does it actually look like in practice? Well, to find out, we're diving deep into our source material to solve a royal riddle called the stones that shine. Get ready because the numbers we're about to look at are going to absolutely explode in size. Okay, let's dive right into this with the opening lines of our royal riddle. The poem goes, 3 daughters with curious eyes, each got 3 baskets, a kingly prize. Honestly, it sounds like a totally standard, innocent fairy tale setup, right? A king, his daughters, a few thoughtful gifts. There is nothing mathematically intimidating here at all. So, picture our cast of characters. A king standing proudly with his 3 daughters. At this exact moment in the story, we're just looking at a tiny group of people receiving a few baskets. It's a very humble, simple starting point. But, and this is a big but, don't let this peaceful setup fool you. This story is actually a perfect disguise for a set of numbers that's about to multiply way more rapidly than you might expect. All right, so the story continues and hands us our next clue. Each basket had 3 silver keys. Let's actually track this. We have 3 daughters. Every single one of those 3 daughters has 3 baskets. And inside every single one of those baskets, there are 3 silver keys. We're starting to layer the number 3 on top of itself. Now, the very next line of the poem tells us that these keys have a specific purpose. Each opens 3 big rooms with ease. So I want to ask you directly, try to do the quick mental math right now. If we take our daughters, multiply by their baskets, and then multiply by the keys they hold, how many keys do we have in total that are about to open these rooms? Did you get 27? Because if you followed the math, that's it. 3 daughters times 3 baskets is 9. 9 baskets times 3 keys each gives us 27 silver keys. We literally haven't even opened the room doors yet. And already, look how quickly our numbers are starting to scale up from that initial group of just 3 people. Well, let's see how this builds. The poem goes on. Each room had tables, 1, 2, 3, with 3 bright necklaces on each, you see. Okay, so those 27 keys open 3 rooms each. Inside every single one of those rooms, there are 3 tables. And resting on every single table, there are 3 bright necklaces. The multiplication is escalating drastically with every single line of this poem. So at this point, we've kind of got a real problem on our hands. How do we keep track of all this treasure? Keeping these constantly multiplying numbers in our head is getting incredibly tricky. If you're trying to picture the daughters, the baskets, the keys, the rooms, the tables, and the necklaces all at the exact same time, your brain might be spinning a bit. We definitely need a better, more structured tool to visualize this explosion of items. And a simple tree diagram brilliantly maps this exact growth out for us. Imagine the 3 daughters at the very top. From each daughter, the branches drop down to 3 baskets. From each basket, branches drop to 3 keys, and then finally down to the rooms at the bottom. Just by following these branches, we go from 3 people to a massive spread of 81 rooms. But here's the catch. Imagine if we kept drawing this visual tree for the next steps, the tables, the necklaces, and the diamonds that are still to come. The diagram would be absolutely huge. It would run right off the edges of your screen. We'd be left with this ridiculously long, highly repetitive multiplication problem. 3 times 3 times 3 times 3 times 3 times 3 times 3. Drawing it out is way too messy, and writing it out is just plain tedious. And this is exactly where we introduce our mathematical superpower, exponents. An exponent is basically a super clean way to bypass all that manual counting and repetitive writing. We write it as a base number raised to a power. That big number at the bottom is simply the number being multiplied. And the little number up top, that just tells us how many times to multiply that base by itself. It's a brilliantly efficient shortcut. Let's actually walk through this clear, step-by-step, repeated multiplication to show exactly how exponents capture what we've been doing. Step 1. 3 daughters times 3 gets us 9 baskets. Step 2. Take those 9 baskets times 3, and we have 27 keys. Step 3, 27 keys times 3 is 81 rooms. You see the pattern? We're just taking our previous total and multiplying it by our base number of 3 over and over again. So the crucial point here is the stunning difference in how we can write this. Instead of writing a long, exhausting string of 3s to figure out the total items at the very end of our poem, we just use the elegant exponential form, 3 to the 7th power. It communicates the exact same massive calculation, but it fits neatly onto a single line. This is exactly how mathematicians tame giant, rapidly snowballing numbers. All right, let's bring it back to the grand finale of our poem and set up our ultimate calculation. The story concludes. Each necklace had 3 diamonds, so fine. Can you count these stones that shine? We have successfully traveled down 7 entire layers of multiplication. Daughters, to baskets, to keys, to rooms, to tables, to necklaces, and finally to these shining diamonds. It all boils down to this one single challenge. What is 3 to the 7th power? I want you to try and calculate this math formula right now to finally solve the mystery of the shining stones. We already know how fast it was growing when we just had 81 rooms, right? So how big does the number get when we push it 3 whole layers deeper? Now, what's really interesting about how we solve this is that there's a clever mathematical shortcut. We don't actually have to multiply all those 3s from scratch. We already figured out that the first 4 layers, the daughters down to the rooms, is 3 to the 4th power, which equals 81. And the next 3 layers, the tables to the necklaces, is 3 to the 3rd power, which is 27. Because of the rules of exponents, to find 3 to the 7th, we can simply multiply our 2 known chunks together, 81 times 27. And when we do that, we get our dramatic final answer, 2,187 diamonds. Just take a second to really appreciate that. We started this explainer with just a king and 3 daughters. But through the sheer, surprising power of exponential growth, just by compounding a tiny base of 3 over 7 steps, we exploded into thousands of shining stones. No way, right? That is the true magic and, honestly, the true power of exponents. They describe things that start out deceptively small, but then grow at an absolute breakneck pace. So as we wrap up this explainer, I want to leave you with a thought to chew on. If a simple little fairy tale puzzle about baskets and keys can multiply so furiously into over 2,000 diamonds, where else does exponential growth hide in plain sight in our real world? Think about technology, population growth, or even how a virus spreads. The math is quite literally everywhere once you know how to look for it. Keep exploring, and thanks so much for learning with us today.